a walkthrough on P1, higher, 2015. Question 2. So, P1, higher. Let's jump in. Question 2. Question 1 was done in an earlier video. Let's see what we've got here. Oh, like stars. Question 2. Stars. Our sun is a main sequence star. It will stay as a main sequence star for millions of years, radiating. I like that word. It means giving out. Our sun was formed from a nebula. That's a big cloud of gas. Describe. So I need to put some facts in an order, starting with nebula and going to main sequence. Right, so I can begin at nebula. I can recall that the next stage is protostar. And then we get into main sequence. So there aren't many stages to refer to here, but we need to describe some facts. So the nebula is a gas cloud which condenses. That means it comes together like that. It gets, and under gravity. So gravity causes that. The protostar is when the kinetic energy from gravity, you see these particles, we've got a gas cloud there, no harm in doing diagrams, will clump together, condense, get denser, and the kinetic energy will need to be transferred at some point. These particles will need to slow down as they get into the more dense regions. Now this is what we call a protostar. The kinetic energy that was gained by gravity begins to be transferred as heat energy. You could use the word thermal if you're feeling posh. And what we have in a main sequence star, what makes a star is that the pressure from gravity combined with heat causes atoms to fuse together and release energy. So the atoms basically get crushed. The star is an atom smashing machine, and the atoms get fused together right in the middle, and it gives out light and heat when it does that. We'll learn much more about that in P2, but this is the P1 module. So if you are doing this as a triple scientist, just be careful not to get carried away with this is testing P1, not P2. It's not asking about your knowledge of nuclear fusion. It's asking you to describe the formation of our sun, which you did in P1. Our sun will go through many stages. Which of these stages will our sun go through? Now we need to know, this is something only for the higher tier. The sun is a fairly average to small star compared with all the other stars out there, and only the really big ones will end up as black holes. So it can't be that. And supernova, that's what tends to happen to the really big stars before they collapse into black holes. Which of these stages will our sun go through? It's one of these two. I'll lead you to look up and decide which is the correct answer. Part B. Lines in a spectrum of light from a galaxy. This is the colours, the spectrum, the colour spectrum of visible light. Line X will be in a different position from a more distant galaxy. More distant. So the universe is expanding. Galaxies which are further away are moving away faster. They are stretching the light more, which means that the light from the galaxy will have a longer wavelength. So anywhere to the right of there should be okay. And now I've jumped ahead because that needed to be labelled. Why? Read the whole question. Explain why you have drawn. Oh, well, I just did that out loud. So, further galaxies move faster away in an expanding universe, which causes light to be stretched, and therefore we see this effect of an increased wavelength, which we call red shift. Now, I personally would take a lot more time about that, explain why. But I've just noted down some of the key ideas. Part C. Two theories are steady state and Big Bang. I remember those. Which row of the table applies to steady state? Now, before I even look, people often think the steady state doesn't mean expanding. It's okay. They accepted that. So the universe is expanding. They said that was okay. But they had an issue with it having a beginning. They didn't think the universe had a beginning. So it must be that one. State the name of the discovery that persuaded most scientists to prefer the Big Bang Theory to the... Right, I wonder if I will get... Now we only need to state... It says state the name, so maybe just putting the letters won't be enough. We don't need to explain. Cosmic microwave background radiation. It's 1 mark, I guess, so we just need to write that. States. But what it is, if we needed to describe or explain, it is the leftover heat and light from the Big Bang. And as space expanded, those wavelengths expanded with it. And what we have now is... you could almost call it like a wallpaper, but in all directions, in all of space, there is this background of microwaves. and we could almost call this a smoking gun. It's the evidence that at one point, at one time, there was a singularity that expanded, and it does support the theory of the Big Bang, that heat and light from a Big Bang, from an explosion, has been stretched, expanded, and is today we can see it as this cosmic microwave background radiation. Oh, I need to lie down. It's a lot to take on board.